All right. We're starting with the PowerPoint. Right, so the first thing we have there is the different types of data that we can get. Now, discrete data is the one, and continuous data is the other one. Now, discrete data is information collected by counting. Now, that is a very, very nice way of explaining discrete data. Okay, so if I count the number of people here that performed in a certain place, I cannot get a number in between. It cannot be 3.5 people or something like that. It's specific numbers like that. But continuous data is measuring, so we know we get a lot of decimals, or fractions. So information collected by counting is discrete, and continuous is measuring. If I can give you a visual way of remembering it, discrete data will be indicated if you have a graph. Let me just quickly get a calculator here. Discrete data will have specific dots there representing it. Okay, so you can't make a reading in between. So if I take the rainfall for January, February, March, April, May, I can't go and take a reading between February and March and say, well, that was the rainfall for the 15th of February. Does that make sense? Okay. They are independent from each other. Whereas continuous data will be a line that has some sort of pattern. Okay, so like a straight line graph. You can take readings in between because it's continuous. Because you can take the fractions in between. Okay. Right. Next up, ungrouped data. That's what we were working with yesterday and the day before, or last week. Now, they say the data below shows the number of laptops sold by 15 sales agents during the last financial year. Okay, do you think this is discrete or continuous data? Discrete, no? Okay, they are counting it. Very important, arrange every time from the smallest to the biggest value. Now, in actual fact, it doesn't make a difference whether you arrange it in ascending or descending order, but it just makes a lot more sense having it in ascending order, no? Okay, so there it is arranged. Next up, very important. The mean, you know that, the sum of the values divided by the number of values there. So just look at the symbols used for it. I also use the sigma sign. So sigma means sum of. The sum of x's divided by n. Okay, and then you know how to do it. Okay, I want you to take out your calculator. Do you all have a Casio? Or let me ask, is there someone that does not have a Casio? It doesn't have to be exactly this Casio, but like the sharp works differently. You all fine? What do you have? Okay, I'm not sure about the functions of that calculator. Okay, we'll try to figure it out. You'll come to me and then we'll try to figure it out. If we can't figure it out, I don't know, we'll Google it. Okay, we'll try to make a plan. Okay, so I want you to start by pressing mode and then you choose 2. That's stats. Okay, then you see there are many options there. We want to choose option number 1, VAR. Then you'll see you've got a table on your calculator. Okay. Enter data points. So what you're going to do is you're going to take all of those values there. You press 34 equal to, 37 equal to, 43 equal to, 46 equal to 48 equal to 48 equal to 52 equal to 54 equal to 58 equal to 62 equal to 68 equal to 73 equal to 78 equal to 84 equal to 90 equal to. And then you check, you should have 15 values. Then you see there you have to press AC, all clear. Then it's gone. Good. Alright. Now we're going to calculate the mean using our calculator. Okay? So you don't have to do anything. You're just going to press Shift 1. You see at the top of 1 it says Stat. And then 1. Okay. There's a typed just at the top of your number 1 button. It says Stat. Okay. So when you press Shift, it uses the yellow options. That's what you are activating. All right. Next, we're going to choose number 4. Again, VAR. Now, I just want you to see there, if you press 1, it will give you the number of values that you entered, but you all know that's 50 now. That's not something we want to calculate. When you press number 2, the X with the line at the top, that's the symbol for mean. Okay, so if ever you see an X with a line at the top, that means mean. Now, let's quickly calculate the mean. So you choose number 2, and you press equal to, and then you should get 58,3333333. Do you see, when you look at the PowerPoints that I handed out there, and here at the top, the mean calculated was 58,33333. If you did not get that, you did not enter the values correctly, but I will come and help you now in a second as well. Now there's something else that we are going to learn about that they always ask in a question. It's called the standard deviation. Now, I'm quickly going to show you in the textbook. You don't have to open there right now. Obviously, guys, I just want to say you are going to have to know these steps by heart. Okay. Now, the standard deviation is it's a measure, a tendency, a measure of measurement, of spreading. Okay, you remember like range was a measure of how far it's spread out. Okay, so the standard deviation does that as well, and then we also get the variance. But the variance is just the standard deviation squared. Okay, now when we calculate the standard deviation without a calculator, what we would do is we would have our values of our data, we would calculate our mean. Then we would say the data minus the mean, then we get our answer, and then we square it. Okay, because some of the answers will obviously be negative. So the standard deviation has a lot to do with the mean. It's like saying how far is the data value or all the data spread from the mean. You remember the two situations that I gave you. The two classes, one scored, all of them got 50%, and then the mean was 50%, and then the other class, that half of the class got 0 and the other half got 100, and the mean was still 50%. So this standard deviation has a lot to do with that, because then you can imagine you will have a very big standard deviation when it's 0 and 100. Whereas if everyone scored 50, the standard deviation will be very small. So how does the values, the data, deviate from the mean? Does that make sense? Okay. So you would take the data minus the mean, get your answer. You would do that for all of them. And then you would square all of those values. And then you would add all of those values. Okay? And once you added all of that values, that will give you S squared, which is the variance. But we want to find the standard deviation, so then you would take the square root and you would get the standard deviation is 15,7. Now normally what we would do is we would then take the standard deviation, subtract it from the mean and add it to the mean and see how many of the data fit into this interval that I've created. So it's the mean minus the standard deviation and the mean plus the standard deviation. If all the data fits into one standard deviation, then the data is very close to each other. It's not very spread out. That would be like the class that everyone scored 50%. If you have to add and subtract two standard deviations on both sides, and the data fits in there, that means you used two standard deviations. So it says that it's spread out a little bit more. And then if they still don't fit, you can use 3 standard deviations and then 4 standard deviations. So the more standard deviations that you need to add and subtract tells you how far this set of data is spread from the mean. Does that make sense? Okay. But do you see it's a very big job having to do this? Okay. And it counts 2 marks. Right. So that's no problem. On our calculator, and you can check it there on the page that I gave to you as well, you can press all clear again. When you press all clear, your set of data is still in there. Go. You're going to have to clear all to get rid of that set of data. But now that data is still in there. So once again, we're going to press shift and stat, the one that says stat. Then we choose 4 again, variance. Okay, and then you can look here on the page that I handed out to you. It says there, if you want to find the standard deviation, you're going to use that omega and X button, number 3. So you press number 3 and it gives you the standard deviation immediately, 16,49. 16,49. Does that make sense? Okay, so this is everything. All of this you're going to have to study. You have to know it. Now, we have all of the values on this page. Okay? Let's quickly check out. If we say 58,33 minus 16,49, it gives me 41,84. You see, it will be here. There are 2 values out of 1 standard deviation. If you subtract it again, it's 25,35. So that means all of the values to the left is included in 2 standard deviations. Then we check it to the other side as well, 58,33 plus 16,49. That gives me an answer of 74,82. I add it again, 16.49. It gives me 91,31. So do you see all the data within 2 standard deviations? That's how we use the standard deviation. Okay. Now, in order for you to clear your calculator, you're going to look there above number 9. It says CLR, clear. But you see it's the one in yellow. So therefore I'm going to have to press shift, clear, and then you say 3. You want to clear all of it. Equal to AC, now your calculator is clean. It's no longer in stat mode, it's in normal mode now. So you're going to have to put it back into stat mode if you want to use the stat mode again. Right, so just going back to the two things we saw here, you see there are basically two steps or two different steps. The first one is getting it into stat mode and then entering the values that you want in your data set. The second one, when you press shift 1, that's when you're going to choose whether you're going to calculate the mean or the standard deviation. Are you happy with that? Understand? Okay, we're going to practice that as well. Right, the next ones you know. The mode, the value which occurs most often, they say it's 48. We agree with them, it was the one that occurred twice. The range is the largest minus the smallest. The median is the middle value, and very important, when the data has been arranged. The lower quartile, I spoke to you about that, don't use that formula. The upper quartile, and something you will see next to it there in just after Q1, it says the 25th percentile and the 75th percentile. Now, just to quickly talk about that, it's not something that we use a lot, but you know a quartile, we said it divides the data into quarters, so we could get the 1 quarter, that's the lower quartile, we get 2 quarters, that's the median, we get 3 quarters, that's the upper quartile. What does the word percentile sound like? Percentage, okay? So with the percentile, you can get 10% of the data. You can get 90% of the data. What they can ask you is, for example, what does it mean if the class wrote a test and the 10th percentile is at 30%? Then you're going to say it means that 10% of the class failed, because 10% got less than 30. If they say the 19th percentile is at 50%, what does that mean? It means only 10% of the class got more than 50% for the test. 90% of the class scored less than 90%. Okay, so you must be able to give your own opinion about what it means. Right, there's the interquartile range, you know that one as well, Q3 minus Q1. The 5 number summary. This is they say here the mouth and whisker diagram. The container and dot, I know it more like the box and whisker diagram. That's the way we use it. This summary is from a different province. Okay, so that's just why the wording sometimes differ. Now, you can just look there. We haven't really spoken about the box and whisker, but we are going to speak about it at a different date. But it's only 5 numbers that is given in a diagram. It's very easy. It's the minimum value. So, in this case, 34. It's the maximum value, 90. It's Q1, Q2, and Q3, which you know how to calculate, the 3 quartiles. Then the minimum, some people use a line there, some people make a dot. And then the maximum we make a dot, and then Q1, 2, and 3, we draw the lines where they are. For the quartiles, we close it in a box, and then we make the whiskers to the maximum and the minimum value. Would you be able to do that? Okay. So oftentimes they give you a box and whisker, and then they ask you, calculate the interquartile range. Then you need to know the interquartile range is Q3 minus Q1. But they won't give you the box and whisker with these words there. You're going to have to know, what does the box and whisker represent? Minimum, Q1, Q2, Q3, maximum. So then I know I'm going to take Q3 minus Q1. And then you're literally just reading it from the number line, the value. It's that easy. Go. we spoke about outliers. You remember? Okay, now, up until now, if you did statistics, you would have to just look at the data and then determine whether you think there's a number that might be an outlier or not an outlier. So this is another thing, formula that you're going to have to learn. We're going to say the first quartile minus 1,5 times the IQR. The first quartile value, 46, minus 1,5 times 27, which is the IQR. It gives you 5,5. If there's a value smaller than 5,5, that value will be an outlier. Then you do the same thing, but you plus it to the upper quartile. The value is 113,5. If there's a value greater than 113,5, then that value is an outlier. But in this set of data, there are no outliers. You good? Distribution of data, definitely an exam question. How is the data distributed when we look at the median and the mean? Okay, if the median and the mean are equal, like in this case, here we can see it in the box and Whisker, everything is symmetrical. Right. If it's given in a graph, you see it starts low, it reaches a maximum, it goes down. If it's symmetrical, we say it's normally distributed. Normal. If it's distributed like this green one, the median is to the left. That means the mean is on the right-hand side. Then we say it's skewed to the right. Skewed to the right. The mean is bigger than the median. The mean is bigger than the median. Skewed to the right. If the mean is smaller than the median, it's to the left of the median, then we say it's skewed to the left. You will see that they say that it's positively skewed or skewed to the right, negatively skewed or skewed to the left. It doesn't matter which wording you use. I think skewed to the left and skewed to the right is easier because you just have to learn if the mean is on the right hand side, skewed to the right. The mean is on the left hand side, skewed to the left. And then you're done. Happy with that? You must know that page very well. Right. Okay, yesterday we worked with the frequency. Remember the frequency, right? The frequency is the number of values, and then we used we drew the histogram, and then we drew a frequency polygon. You remember what the frequency polygon was? That's when you make a dot in the middle of the, like this is a frequency polygon. Then, when we make a dot in the middle, and then we join the line, the points. That was the frequency polygon. Now that must not be confused with what we are doing today. Today we are looking at the cumulative frequency, and you will see next to cumulative frequency it says ODIF. So it's got two names, this one. Okay, let's go to the first page. Right. The first column you know, that's the intervals, ne? The second column you know, that's the frequency. The third column you don't know. That's the cumulative frequency. Now don't be confused with all those arrows there. I'm going to explain to you. If you want to get the cumulative frequency of the second interval, you add the frequencies up to date. So you're going to say 0 plus 3 is 3. If you want to get the cumulative frequency of the third interval, you're going to say 0 plus 3 plus 7, that gives you 10. Or you can just take the cumulative frequency of the previous one plus the frequency of the next one, it will also give you 10. Does that make sense to you? Okay, so every time we're just going to add the frequencies. If I want to know where does this 113 come from here, it's 28 plus 85. Or it's 28 plus 34 plus 19 plus 14 plus 8 plus 7 plus 3 plus 0. That's what these arrows are doing. Okay. So you take the previous cumulative frequency, you add the new frequency, you get the new cumulative frequency. Do you understand that? Is it hard? Thank you, Wolfgang, for your positive outlook on mathematics. Right. Next up, determine the average and the standard deviation. How to use the calculator for grouped data. Okay, so let's start. Clear your calculator, shift 9-3. Clear all, clear all. All right. Press shift mode. The down arrow. Your circle that has an arrow, just press down. You choose number 3, stat. Then they ask you frequency on or off. We want to put it on. So we choose 1. Okay? Then you're going to press mode. You choose number 2, stat. You choose number 1, VAR. Then you've got a table with x's and a frequency. Okay. Now we're going to enter the data. You get the average of the point of the interval. That's the midpoint, ne? So 0 to 10, what's the midpoint? 5 equal to. We'll go first in one column. Okay. Then 15 equal to. Then 25 equal to. Then 35 equal to. 45 equal to. 55 equal to. 65 equal to. 75 equal to. 85 equal to. 95 equal to. Then you use your arrow to get into the frequency column. How many values must be there by 5? The midpoint, where the midpoint is 5. What's the frequency? 0 equal to. Frequency of 15. 3 equal to. 7 equal to. 8 equal to. 14 equal to. 19 equal to. 34 equal to. 28 equal to. 5 equal to. 2 equal to. Okay. Are you happy? You can double check it in the exam. You definitely double check it. Okay. Because now you won't know where the mistake is. You won't even know you made a mistake. Okay. And there's no calculations to show. Right, all clear. we are going to first find the mean. You know how to do that? That's the second one there. So you press shift and 1 to get to stat. Then they say they press 3, but you see on your calculator VAR is 4. Just change it on your page there. Okay. Now, first the mean. Which one shows the mean? 2. And equal to, then you get 59,1666666. Round it off, 59,17. Is it cool, Kumo? Did you double check? Okay, then all clear. Then shift stat or shift 1, choose number 4, choose number 3, the standard deviation. 17,30. Good. We got that. Okay. This is how to turn the frequency off after starting the question. I don't think it will really be necessary. Just clear all. Okay. Alright, the next one. The learners were told if you get 40 or less mark, you must rewrite the exam. If you get less than 51 but more than 40, you will not need to rewrite the exam. You will need to write an extra essay. If you get more than 80 but less than 91, you will get an A. If you get 91 or more, you will get an A+. Okay. Use the table to answer the question. How many learners must rewrite the exam? Okay, so it's up to 40%. Do you agree with me? Now you can add all of those 1 plus 3 plus 0 plus 3 plus 7 plus 8, or you can just read the cumulative frequency, which is 18. How many learners must rewrite an essay? Okay, do I want the cumulative frequency? No, I just want the learners between 40 and 51. That will be 14. How many learners received an A? The learners that received an A is between 80 and less than 91. So therefore, it will be, it's an A+. Sorry, it's an A+. I didn't see it there. So it will be between 91 and 100, therefore it will be 2 learners. How would we give the answer for learners that got A? It would be 5. Do you agree with that? Okay. How many learners got less, or how many learners did not get an A? 113. Because the cumulative frequency gives us all the values up unto that one. You understand cumulative frequency? Okay. Now, when we have the cumulative frequency and we represent it in a graph, the graph is known as the cumulative frequency table, or it's actually called a OGIF. Now, the thing about a OGIF, when you plot the OGIF, it always makes an S shape. You will remember that. I'm Salome, I'm your math teacher. It will be an X. Okay. Let's look at the next slide. We can obtain median and quartiles of the cumulative frequency table. There are 120 marks for learners. This means that the median is between the 60th and the 61st value. Which interval is that? Now you don't even have to go and add them like we did it now. You remember? For homework. We can just go and look, where do you think the 60th and the 61st value will be in? There by 85, ne? And then it's going to be 60x greater than 60 or smaller than equal to 70. The lower quartile is between the 30th and the 31st value. What is the interval of the lower quartile? So you go and look there. There's 32, so it's going to be 40 to 50. The upper quartile is between the 90th and the 91st values. Which one is it? 70 to 80, there where 113 is. Easy. Would you be able to find that position? Yes. You would say n plus 1 divided by 2. You'd get the answer. Or, and then with the lower ones, you can say the 60th number was no, it was between 60 and 61, so there are 60 values below. So you're going to say 60 plus 1 is 61 divided by 2 gives you 30 and a half. That's how they knew it's between the 30 and the 31st. Does that make sense? Okay, and the same for the upper quartile. Right. A record was kept of the number of runs scored by the top batsman in all the matches in one-day local cricket series in 2018 and 2019 season. So, number of runs, there is our interval, frequency, and then the cumulative frequency. How did I get the cumulative frequency? They add the previous frequencies. Draw an ogive of the results. Okay. The first thing that you get a mark for when you draw the ogive is this long line here. Did you anchor it? Did you anchor it? Alright? Now look at how we would plot it. You use the upper border to plot. So you see your interval's got two values. You don't use the lower one. You don't use the midpoint, you use the upper value. So therefore the first point you will plot is 20 and 9. 20 and 9. Then 40 and 34. Then 60 and 72. Then 80 and 120. Then 100 and 149. These values here, I just want to say, on this side, those are the cumulative frequency values. Ne? It's not the frequency, it's the cumulative frequency. 120, 155, 140, 160. So you can imagine once you've plotted it, you started there. Look here on the board. You started there. So it would not be anchored. That's why you have to anchor it. And you anchor it to the first value there. That's the only lower one that you use. Then you don't use a ruler. You use a free hand. And you make a smooth curve. And then you've got your ogive. Use your curve and answer the following. Alright, what was the median number of runs required? You get the position, 80,5. Then you go, and this is also an estimate, because you're going to use your graph. You go to the frequency side, the Y values, and then you go and read it off there. That gives you the median, plus minus 64. Then you get the position, and here, this is the only place that I would suggest using the position with dividing by 4 and multiplying by a quarter and multiplying by 3/4, because this value can be estimate. Do you understand? Okay, so 40,25, then you go and read it off. Where's 40,25? That's your Q1. Q3, you'd say 160 plus 1 times 3 quarters, you get your position 120,75 and you go and read it off the graph. Are you happy? Then they ask, which deductions can you make of the value of the interquartile range? So how many learners or players or how many runs is between the interquartile range? So you had Q1 is 120, Q3 is 120, Q1 is 40. When you subtract, you get 37. Okay? Do you agree with me? Then how many players will that be? How many players will be between interquartile 1 and interquartile, or quartile 1 and quartile 3? Half of the players. Because 25% is less than Q1, 25% is more than Q1, so 50% is in between. Estimate the number of times a score of 35 or less has been obtained. So you go and look where's 35 scores. There's 35. How many times? It's an estimate, it's 27. The batsman who scored the 5 highest runs in the league got medals. What is the lowest number of runs that qualify for a medal? Okay, so they say the 5 highest numbers. The 5 highest numbers. So if there are 120 players, or 160 players, how many will get medals? 5. So where do we draw the line? 155. And then the number of runs will be here. So it's plus minus 111. So the most difficult part is knowing when you're going to start at the y-axis and take the reading from the x-axis, and when you're going to start at the x-axis and take the reading on the y-axis. Okay. Draw a container and dot, mouth and whisker, box and whisker to illustrate the player's results. The lowest number of runs scored was 0 and the highest number of runs 139. And there you have it there. Okay. Do you all understand that? As I say, you need to know that very, 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 very well. Okay. You are going to do for me exercise 2, page 299. Exercise 2, page 299. Only number 1. Okay. Only number 1. They've given you information there. Page 299. Then they've given you the frequencies. You're going to fill it in the frequency table. Then you're going to determine the cumulative frequency. Then you're going to draw cumulative frequency graph. So that's a give for the data. Now listen to me. The marks scored. The marks scored. Just like this example. The number of runs comes on the x-axis. The cumulative frequency is on the y-axis always. Okay, so you're going to draw the ogive. You determine the quartiles. You know how to do that, no? The number of learners of the number of data plus 1 divide by 2 for the median, divide by 4 for first quartile, and times with 3 quarters, or times with 3 and divide by 4 for the upper quartile. Then you go and read the position. Okay. And then they're asking you to determine the 90th and the 10th percentile. I just want to say there, it works the same way. We multiplied with a quarter and a half and 3/4, ne? So for 90%, you know how to write 90%, 0,9. So now you're just going to say, don't add the 1 there. Just take the number of values. If it's 200 players, 200 times 0,9, you go and read it off. So with the percentile, you don't need to add 1. Okay. All right, you do that for me for tomorrow, please. And you learn this page. You must know it very well.